Hi, my name is Patrick Daigle. I am part of the product management team in the Cloud Native Applications business unit at VMware. And today I'm going to take the next few minutes to talk about vSphere integrated containers. So what I'm going to do today is I'm going to give you an overview of the different components that make up the solution. And then we'll go over some of the steps that are necessary to install and configure the solution. And at the end, I'll go over some of the workflows of how your end user or your developer would actually use it. So throughout all of this, I'll be talking about the different personas who are involved as well in setting this up, managing this, and consuming this in your environment. So with vSphere integrated containers, we start with an existing vSphere environment. So you don't need to dedicate any infrastructure to this. You can set this right up in your existing vSphere environment. So we actually support running on vSphere Enterprise Plus and on vSphere Remote Office, Branch Office, Advanced. And the reason for this is that we actually have a dependency on the vNetwork distributed switch. So this will also work with NSX. So this can also consume NSX logical switches. Logical switches actually provide a very elegant solution to the isolation of the bridge network. And then you're able to leverage any other NSX constructs as well, so you get all the benefits of the distributed firewall. So you can actually provide microsegmentation for your container images that are instantiated on vSphere integrated containers. So I'm showing an embedded PSC in this picture. You can use an external PSC as well. I'm just using an embedded for the purposes of this, but we can actually use the external PSC as well. So we start with the vSphere infrastructure. So the first persona we're going to talk about is the VI admin. The VI admin will be responsible for doing the initial installation and setup of the vSphere integrated containers solution. So the first thing that they'll want to do is to deploy the VIC OVA. So the VIC OVA is available on the regular VMware downloads website. So you can get it there, and it deploys just like any other OVA on top of your vSphere infrastructure. So here's my VIC OVA. After the initial boot up, you need to initialize the OVA. What this means is that you actually need to connect it to the vSphere Platform Services Controller. And we use this integration to provide role-based access control for the users that we're going to define in my VIC solution. So the users and groups are coming from the PSC, so if you have anything like AD or LDAP integration that you've configured in the PSC, they become available as well in the vSphere integrated container solution, and you can start assigning roles to them. So we do this RBAC through the use of the Platform Services Controller. Once this is initialized, this will come up and you'll get a number of services. So there's a couple of key services that we have in the VIC solution. The first one is the management portal. This is based on Project Admiral. That's a VMware open source project to provide container management. So this will provide you visibility into your container hosts, into your actual containers, provide you visibility into container networks, container volumes, and then allow you also to deploy infrastructure, manage users, projects, and things like that. And we'll get more into that when we go to the other personas here. The other key component is the registry. So most customers who start in their container journey realize very quickly that they need an internal or on-premises area to store their container images securely. So we have a built-in registry as part of VIC. That's Project Harbor. That's another open source project by VMware. And this registry provides you with a lot of the controls you need to run containers in an environment that's been operationalized for production. So what do we mean by that? We mean that you get things like built-in replication. So you can replicate your images to a remote site, either for just data protection or if you need data locality things like that. The other thing that we have is image vulnerability scanning. So scanning against known CVEs to identify any known vulnerabilities within the container images when they're stored in the registry. Third thing is content trust. So this allows us to sign images using certificates to prove that they're coming from a trusted source. There's many other controls here. There's videos out there about Harbor and what it provides. So we're going to stick with these for now, but it provides a lot of the controls you need to run this in a production environment. The last component is the VIC machine API server. And that basically provides us with the primitives that we need to create the virtual container hosts. And we'll get back to that in a couple of minutes. So after the OVA is deployed, after the initialization is done, next step is to install the VIC HTML5 plugin. So the VIC HTML5 plugin installs in your vCenter server. So it's actually a vCenter plugin that requires the HTML5 client. And what this gives you is this gives you a graphical way of provisioning the virtual container host. So this is a workflow-based tool that'll walk you through the different steps to configure your vSphere integrated containers container hosts. If you've done this in the past, prior to the VIC 1.3 version, you know that you had to use the VIC machine command line to create the virtual container hosts, and it was not very user-friendly. So this provides a much more user-friendly workflow where we actually guide you through every steps and provide hints along the way to help you make the right decisions of how you associate the vSphere resources to the virtual container host. Because what the VI admin is doing in this step is they're mapping the vSphere resources that they want to make available through the Docker API. Because remember, with vSphere integrated containers, we're trying to create a Docker native experience for the end user. So the VI admin maintains a lot of control by allowing them to decide which and how these resources are presented to the Docker API that we're going to see in a few minutes. And then the developer gets a native experience in that they can use the same open source APIs and tools that they've been using in the past. So using the H5 plugin, my VI admin is able to take the last step in setting this up, and that's deploying the first virtual container host. So using the HTML5 plugin, I will deploy a virtual container host. So what is a virtual container host? Well, it starts with a resource pool. And we use a resource pool because it gives us a way to group the container VMs with their container host. And it also provides us with a very flexible resource management construct where we're able to expand this if we need more capacity, or we're able to restrict it if my container host is taking up too much resources and impacting the other workloads that are running in my vSphere environment. So it provides a very flexible mechanism. One thing to note, resource pool means I'm using DRS, and we actually make extensive use of DRS to do the initial placement of the container host and any container VMs. In the Robo Advanced use case, there is no DRS. So what we did is we use an inventory folder to group these container VMs together with their associated container host. And then the VCH has a very simple algorithm that it uses to make intelligent placement decisions. So what we're doing really with this is we're only avoiding making a bad placement decision. This does not replace DRS at all. There's still a huge use case for using DRS. In fact, one of the most common use cases that we see for vSphere integrated containers is customers who deploy a container host on their existing vSphere clusters, And it allows them to use, you know, that overhead capacity that you have in your vSphere clusters, because you want to be able to do things like HA or failover if you're using a metro cluster. Well, with VCH, you can actually schedule some ephemeral workloads in that extra capacity that you have in your clusters, and then just tear it down when you're done. So a very flexible way, and one of the benefits you get for running this on top of DRS. So we start with a resource pool. We provision one VM, that's my VCH VM. And one of the key things that that VCH VM will give me is my Docker API. So we're exposing a Docker compatible API that's going to be able to answer regular Docker CLI or Docker API calls. We're able to secure this, if you want to, using TLS. So we can use TLS for encrypting the communications to and from the Docker API. And we can also use TLS client certificates to restrict who can access that remote API to send calls. All right, so now we're done setting up the vSphere Integrated Containers environment. So once this is all available and set up, this is where my next two personas are going to come into play. And here, this solution is actually configured and managed typically by your cloud and your DevOps admins. So the cloud and the DevOps admins will actually connect to my management portal. And they'll be able to perform a few tasks. So the first thing they need to do is to set this up and set some users up so that I can actually have a developer come in and use this. So the first thing we're going to talk about is the project. This construct of the project that we have in the VIC appliance should really be seen as a unit of tenancy or as a boundary. So we assign users, we assign infrastructure, and we assign registries and policies to projects so that they can be used to create boundaries around either different teams within your organization, or create boundaries between development and production, for example. These are some of the common things that projects are used for out in the field. And the first thing that you create or assign when you create a project are users. So the cloud admin will create the project, and then their first task will be to assign a user to have the role of the DevOps admin. So where the cloud admin is, their responsibility is to manage the appliance as a whole, the DevOps admin's responsibility is to manage the individual projects. So DevOps admins can manage users within projects, manage the registries, manage the policies within the project. So again, the first thing the cloud admin will do is create a project and assign a DevOps admin user or users to this project. One thing to note is that cloud administrators, when you first deploy the VIC appliance, we will assign cloud administrator role to anybody from the platform services controller that is part of the administrators group. So it ties in well with whatever groups you have that are created already in your platform services controller. So once I have some users defined, the next thing I'll want to do is assign some infrastructure. So I need some runtime, right? I need a place to actually run my container images. So this is where we're going to actually start connecting these container hosts that I'm creating to the management portal. So they can be managed, I can view what they're running, and I can actually start scheduling or instantiating container images on this container host. After I have my infrastructure, I need to configure my registries. So as I mentioned, we have the built-in registry that's Harbor. So every project gets a dedicated namespace or repository within the built-in Harbor. So you can use that as your internal on-premises registry. We also support connecting to third-party registries. So you can connect to Docker Hub or any of the other commercially available Docker-compatible registries out there. So once we have the registry set up, the last thing we can set up are the policies. So I can set up some policies, for example, to have replication done in my environment. I can set up policies around vulnerability scanning. We can actually prevent images that are found to be vulnerable, we can prevent them from being pulled and run from the registry. And we can similarly prevent images that are unsigned from being pulled and run from the registry. So once this is set up, once your project is set up, you have users assigned, that's where your developer can come in and start using this solution. And we're going to look at what the developer workflow now looks like. So how does a developer actually access this and use this for instantiating their containers? So let's look at the developer. Draw my developer over here. The first way that the developer can consume this is by connecting to the management portal. So developer can come in, connect to this web portal, and from there they'll get a view into what images are available in the registry. They can actually deploy these images from that interface. So do a simple container image deployment from that interface. Let's just use container image called my image as an example here. So developer comes into the management portal. They see that my image is available in the registry. They initiate a deployment. So the VIC appliance will talk to my container host. Container host will pull the my image from the registry, and then they will instantiate the container. So one of the key differentiators of vSphere integrated containers when you compare it to other engines is that where Docker, for example, will use the Docker image, and then they'll use this Docker image and use namespaces and C groups to build a Linux container. With vSphere integrated containers, we use the same Docker image, so we use the same building blocks, the same Docker image, the same layers, but instead of using namespaces and C groups, we actually build a VM using native vSphere construct. So when you instantiate the container image against a virtual container host in VIC, you actually get a container VM. So this container VM, we call it a container VM to distinguish it from regular VMs. It's a very lightweight VM that's running a very small Linux container to bootstrap it, and then inside of that Linux environment, we'll start up your application. In this case, the application is called My Image. So VIC is strongly opinionated about having this strong isolation model, meaning that every container image gets instantiated inside of its own VM. So some of the benefits are that you get that VM as a security boundary. vSphere VMs are well recognized as a security boundary. So every container gets its own runtime, basically, that's running separate from the actual management plane. That's another key differentiation, right? The management plane here is running completely separately. So you don't run into as many issues with isolating containers from themselves or isolating containers from the container host. In this model, every container is instantiated inside of its own runtime. So you get all the benefits from the VM as a security boundary, and as well, from a scheduling perspective, you get all the benefits of running on top of vSphere. vSphere is very, very good at scheduling workloads. And because we're provisioning these as VMs, they're first-class citizen, and vSphere can work all of its magic, either with the dynamic resource scheduler, HA, any of the distributed services. You can actually monitor the network traffic coming in and out of this now. It's very easy because it's an actual VM, so any type of network flow monitoring tool you have in the environment will actually pick up all the traffic. So easier to leverage all of your existing vSphere tools and processes because these are now first-class citizens in your vSphere environment. The other thing I can do from a developer perspective when I'm accessing this management portal is I actually have this application template format in the management portal that allows me to create configurations that are a little bit more complex and that are made up of more than one container and require certain network constructs or certain volumes. I can actually create that, capture that as a single unit, and then deploy or instantiate it as a single unit. So there are two ways to do this. You can use, this has a built-in graphical designer where you have a canvas and you can assemble the different container images with their networks and volumes. The other option is you can export, import YAML files as well. So you can export its own template format, or you can import actually Docker Compose file using the tool. All right, so this graphical way of accessing the environment is interesting and useful, but in a lot of cases when I talk to customers, what they're really looking for is a programmatic way to consume this. And that's where exposing that Docker API becomes very interesting, because my developer can actually come in and talk directly to the Docker API using the familiar Docker command line interface or the Docker API. So the Docker command line interface is the Docker command, you know, Docker pull, Docker run, these types of things that you can run against this Docker compatible API. And then you can use as well Docker API. So if you've built any type of automation tools in your software development lifecycle or others that make use of the Docker API, you can actually point them at this remote API endpoint and it'll work. So how do I interact with this? Well, I interact with this using Docker. So Docker pull, for example, if I want to pull an image from my registry, I can also do a Docker run. Again, if I take the example of my image, I do a Docker run my image directly to this Docker API. Docker API will pull it from the registry, and a new container VM will get created running my image. So you can see now why we use this resource pool or inventory folders in the case of Robo to group these together, right? I want to keep these container VMs that belong to this container host. I want to have some kind of logical grouping to keep them together. So this is where this becomes important. Once this is up, you know, I can use other commands like docker exec if I need to interact with this container, or I can use docker cp, for example, to move data in and out of this container. All these commands are available directly through the Docker API. So we're really creating a Docker native experience for our developer. And that's one of the key benefits here. As we've seen, from the VI admin perspective, they deploy this using familiar vSphere tools and constructs. They manage this using familiar vSphere tools and processes. You know, all of these things are first-class citizens in the vSphere environment. So VI admin on a day-to-day basis can see what container VMs are running, who started them. They can see what resources are being used. They can control the amount of resources through the resource pool construct, so on and so forth. So from the VI admin, we're creating a vSphere native experience. And then from the developer standpoint, we're creating this Docker native experience where they can consume this using the familiar open source Docker CLI and API, or if they choose to, they can also use the management portal, which provides this user-friendly way of getting started with the tool. So with that, I thank you for your time and have a great day.